Today's lesson on covalent compounds falls into the same learning goal we've talked about for the past 3 weeks with both ionic and covalent compounds. It says through inquiry and exploration, students will be able to understand that bonds hold elements together in specific ways to form new compounds that are then represented by specific chemical formulas and nomenclature. And you'll especially see that today as we learn how to name and write chemical formulas for covalent compounds. You will find this much more straightforward than what you saw with ionic compounds. You'll master covalent compounds today, but being able to differentiate them from ionic compounds will take a little bit of work. Our essential question is how chemists name and write chemical formulas for covalent compounds. At this point, you should be able to draw structural formulas for covalent compounds as well as isomers. You'll be assessed on that on your quiz this week. Your Do Now activity looked at shapes and polarities, and you got a lot of practice constructing those compounds in the laboratory last week. Today we're going to name and write chemical formulas for covalent compounds, and we will compare and contrast them with ionic compounds. That's the tricky part today. And the reason why you're paired is we want to make sure that you can explain these concepts to a classmate effectively, and we're also going to look at some real-world examples. Being able to write high-level questions is what truly differentiates a weak A from a strong A student, and you'll have the opportunity to write a question in your Google Form activity. And again, being able to explain objectives effectively is very important to be in that A+ range. An A can be a 4 or a 3, but the easy A, if you will, is in that 4.0 range. Also make sure you brush up on your isomer drawing, because if you can't draw isomers, you're going to have trouble getting into the A range. But I feel very confident that you'll be able to name and write chemical formulas for covalent compounds today. We're going to look at naming covalent compounds and then writing their molecular formulas. The naming is relatively straightforward. You're going to have prefix in most cases, then the name of the element, prefix, then the IDE form. Those prefixes can be found on the back of your periodic table. They will be provided to you, so you don't need to memorize them. For example, 1 is mono, like a monohybrid cross. 2 is di, like a diploid cell. 3 is tri. What starts with tri? Tricycle, triangle, etc. 4 is tetra, tetrapod, tetraploidy, tetrahedron, isn't there a marine creature like tetrahydra, isn't there? Yeah. What starts with penta? Pentagon. So these are the prefixes. These are the prefixes that you have seen previously. We saw these with the hydrates. Now when you name, you've got prefix, element name, prefix, IDE form. You will have 2 non-metals linking together covalently. So Juliana, in a covalent compound, you have a metal and a non-metal or 2 non-metals? That would be ionic, but when you have 2 non-metals, Tiffany, you have... Do you have ionic or covalent if you have 2 nonmetals? Covalent. So 2 or more nonmetals will be covalent. The atom with the lower electronegativity will be first. So those electronegativity values you've seen previously, and let's say that you had N and O. Which element would be listed first, the N or the O? The N, because the electronegativity of nitrogen is less than that of oxygen. 2 or more nonmetals bonded chemically in a covalent compound. Are the electrons shared or transferred in a covalent compound? Shared. The first prefix indicates how many atoms you have of that first element. The word root is the name of the element. Be careful, if you only have one of the first, you never, ever, ever start a compound name with mono. What is the gas that you exhale?
Carbon dioxide.
Carbon dioxide. And so with carbon dioxide, you never start with mono. You just write carbon dioxide. So you never start with mono. If you only have one of the first, it's just the name of the element. The second element ends in IDE, but the number of atoms must be indicated even if there's only one. And we're going to go through several examples here. With oxide, be careful. You must delete the A or the O from the prefix. So for example, we've got those prefixes here. You don't say monoxide, you just say monoxide. So if the prefix ends with O, just lop it off and then oxide. Tetra, penta, hexa all end in A. You don't say tetraoxide, you say tetroxide. So you'll take the A off. So you'll always take the A or the O off the prefix if it's oxide. And I do want to mention in a little more detail that IDE form. That IDE form is exactly what you saw previously. For example, when we talked about monatomic ions, what is the name of this ion? Oxide ion. These are the IDE endings. For example, S2 minus is sulfide ion. So these are the IDE endings that you learned previously. For example, what ion is this? Nitride ion, etc. So you're going to have prefix, element name, prefix, IDE form. For example, in this set, you've got 3 phosphorus, so you have triphosphorus. You have 6 oxygens, so you have hex oxide. I deleted the A as part of that prefix because it's oxide. You have 4 sulfur is tetrasulfur. 8 iodine is octa iodide. You only delete the A or O if you have oxide. Otherwise, leave everything there. Carbon dioxide. So if you only have one of the first, you omit the first mono. But in the second one, what's CO? Carbon. Here you need mono. Delete the O. Oxide, carbon monoxide, that clear colorless gas that can kill.
Wait, for monoxide, what if oxide, like if it was a different one and it didn't start with O, would you keep the
Yes.
the last O on?
Yes.
Wait,
What's the question?
He asked if you would delete the O if you had something else there like iodide, and you would keep the O in that case. You only delete the O or the A if you have oxide. What would this one be, Austin?
Sulfur. Hexafluoride.
Correct. And watch your spelling on fluoride. There's a flu in fluoride. What about this one, Claire?
Nitrogen.
Careful, you have 2 of them.
Oh. Dinitrogen. Yeah. 4 is
but we're going to delete the A.
Tetroxide.
You got it. Also be aware that you never reduce down in a covalent compound. That indicates how many you truly have of each one. What about this one? Sydney, go ahead.
Yeah, Sydney.
Yep. All right. Sulfur hexafluoride has a very interesting effect on the voice. If you...
I'm going to tell you the story of my first love. It happened at Christmas time. November 14th.
If you suck in helium, for example, what happens to your voice? It gets very, very high. Helium has an extremely low density. That's why the helium balloons work so well. Sulfur hexafluoride is much more dense, and let's see what happens to people's voices with this one.
Yeah, my kids are always sucking on a balloon and then they talk to me.
Well, this is kind of helium equals play.
Ooh.
So helium is 6 times lighter, and so sound.
Have you seen this?
We're just laughing at something she said.
This is heavier than air. Thus, it has the opposite effect. So I'll tell you what we'll do here. I'm going to develop a couple balloons here with this.
Is this going to make us gain weight?
Absolutely not. Really?
Gain weight.
So I figured what we do is we do a little post-op maybe, but sulfur hexafluoride version of this.
Sulfur hexafluoride.
Yeah.
And what is the symbol for that on the chart?
That was it's SF6 if you.
I was just testing you to see if you knew.
It's like he's
All right, so here's what we're gonna do with this. I'm hoping this is good stuff. Okay, here we go. Fine. All right, so wait, breathe out. There we go. And you're gonna get the whole thing. Breathe it in. There you go. Whole thing, and a little post track.
oh my god. Can we do that?
You don't want to mess with me. You're the set, put the lotion in a basket.
It's exactly.
All right, so if you want to have any fun with a covalent compound, that may be one way you could do it. Naming, pretty straightforward. All right, be careful with that A or O emission before oxide. Make sure they end in the IDE. When you write the chemical formula, it's grossly similar. You're going to write the chemical symbol for the first element. Its prefix is the first element's subscript. So subscript's under sub, so that's the little number at the bottom. Then you're going to write the chemical symbol for the second element. Its prefix is the second element's subscript. For example, carbon, there's no prefix, so you have one of them. Tetra, iodide, so I4. There's no swap and drop. It's much more straightforward. Trisulfur is S3. Hexafluoride is F6. Dinitrogen is N2. Oxide is O, and the oct is 8. Don't reduce. The subscripts indicate how many of each you truly have. What would the next one be? Go ahead, Kevin. Yep, good job. Next one, phosphorus diiodide. Go ahead, Jarrett.
It'd go in P. P. And then O.
I.
2. PI. 2.
You got it. Iodide. And trisulfur monoxide, Dylan. This Dylan.
S3, like on the bottom, and then
Perfect. Questions on writing the chemical formulas? Pretty straightforward. Isabel's like, this is easy. I've got this. All right. You have 5 minutes. Don't move. Just work with your classmate. And do classwork 2, 3. Number 3 and 4. We'll come around and make sure you're understanding, and we'll check our answers with your partner.
Google Classroom or on
Guys, this is a classwork you already got previously. I indicated that you needed it when you first came in.
I have it.
I have it. That was very nice.
Good job, Dylan. You did a good job.
Kill yourself, Zach. Give me sulfur, tetrafluoride. Yeah. Thanks, Zach. Thanks, dear.
Yeah.
I hate both of Zachs.
Hey guys, let's focus.
Dinitride. I mean, N2. I'm ready. Are you ready? Wait, is that all we need to do? Oh. Good job, I'm green. You're great.
Oh, I have
right?
Wait, why isn't it pentaoxide? Why is it penta?
We've been over this so many times.
Oh,
Hey!
that's the thing with the A and the up. Never
Yeah,
mind.
it is. It's the thing with the A and the
Thank you. Thank you.
All right, couple other things I want to mention to you. Some compounds have common names. For example, with water, we don't say dihydrogen monoxide, we just say water. With ammonia, we don't say nitrogen trihydride, we just say ammonia, glucose. There are many examples of compounds that have common names. However, you will see many compounds, both covalent and ionic, in everyday things. Foods, medication, cleaning detergents, cleaning agents in your household, etc. For example, if you look at the nutrition label of California Sun-Made Golden Raisins, which are very yummy, right here on the ingredients, what covalent compound do you see? Sulfur dioxide. What's the chemical formula? SO2. So you have a covalent compound in raisins. I don't think there would be a food I would hate more than something like that that had peanut butter and chocolate in it. Yuck and double yuck. But when I looked at the ingredient label, there are so many covalent and ionic compounds in this particular protein bar. Sucrose, water, ascorbic acid. You may not be sure of sucrose and ascorbic acid, but you know that water is ionic or covalent? Covalent for sure. Calcium phosphate, magnesium phosphate, zinc oxide, and manganese 2 sulfate would all be ionic. Ionic is where you have your metal and non-metal, or your metal and polyatomic. Covalent is when you have 2 or more non-metals, and with your covalent, there are shared electrons. With your ionic, there are transferred electrons. Be very careful with a polyatomic ion with hydrogen. That is named in an ionic fashion, as you learned, but if it's hydrogen and a polyatomic ion, it's going to be a covalent compound, so be careful with that. Ascorbic acid is vitamin C, and this is a covalent compound. There are no metals, no ions, etc. So ionic and covalent compounds are very much in some of the foods you eat. You'll find them in laundry detergents, medications, etc. And that will all fit into your project that I have assigned you, and I can gladly go over in more detail with you at the end or next time. Organic compounds also have a special naming system. We're not going to get into these in any detail at this stage of the game. You'll see them much later in the year. We've got alkanes, in which you have C's and H's and all single bonds. Alkenes, in which there's 1 or more double bonds. Alkynes, in which there's at least 1 triple bond. And you have other types of organic compounds that also have a special naming system. You'll see different prefaces than you've seen previously. You'll see ethane, ethene, ethyne, but that's for later in the year. All right, with your classmate, write 1 name and its chemical formula for a covalent, and then 1 for an ionic. Let's see how you do with that. If you've got it, then we can move into the last activity in Google Classroom. So with your classmate, write 1 name and 1 chemical formula for a covalent and an ionic compound. Say it again.
Do we just put like any two elements together and put any number after them?
No. Stem elements don't play together. That's not how you name an ionic compound. And you're also not putting the, you have to put the one with the lower electronegativity.
Zach, I literally told you that.
That would be covalent.
No, I told you.
I definitely told you they had to put it in increasing electron negative affinity,
Alright, guys, couple things. Alright, and coming around, I've noticed a few things. Keep in mind with your covalent compounds, you could have something like this, sulfur trioxide. That would, of course, be covalent. In covalent, the element with the lower electronegativity goes first. What I'm seeing in this class is a deficiency in writing chemical formulas and naming ionic compounds. The good news is for Wednesday, you're only going to be assessed on covalent, but on your test Friday, you will absolutely be assessed on both ionic and covalent. So for example, lithium chloride. Calcium fluoride. Remember, you don't typically use prefixes with ionic compounds unless the prefix is part of the polyatomic. So that's something I think you're going to need to review, and we can hit that next time. In your Google Classroom, you have a Google Forms assessment. Before you get there, are there any additional questions?
If you said that the element with the higher electronegativity should be first?
No, lower electronegativity is first. That's why fluoride will never be first. That's why oxygen is rarely first. Lower electronegativity is first.
Why did you say, like, why isn't it like difluoride?
This goes back to your naming, and the reason why you have two of them is you have one calcium ion. You do have two fluoride ions, but with your ionic naming, we don't use prefixes. That two came from here when we swapped and dropped. That's the ionic formula writing and naming. This is going to be from classwork 2.1 and 2.2, and it's going to be from quiz 2.1. And some of you will need to go back, well, all of you will need to go back and review that for your test Friday. Your quiz on Wednesday is just naming and formula writing covalent compounds, drawing the compounds in isomers. Well, you'll have one that has isomers, and then the shape. To wrap it up, I've got a 5-question, like a 5.5 question mini assessment in Google Classroom. You can do that with a partner now and ship it to me. and I can further go over exactly what's on the quiz. But for today, you want to make sure you address that essential question: can you write chemical formulas and names for covalent compounds?